Today I'm partnering with Arnav Sinha from AWS to discuss how Tecton and AWS are working together to support some of the unique requirements we see around the next generation of models, including transformer-based architectures, recurrent neural networks, and other really exciting solutions that we're seeing more and more organizations adopt. So let's dig into the architecture and mental model of a real-time AI ML application. So both Arnav and I, in our roles, get a front view seat on how organizations are leveraging AI and ML to build more intelligent applications that are able to make smart real-time decisions that are driving really positive business value. This is including decreasing costs, increasing revenue, and improved customer experience. So within each of these use cases that we're supporting, there are always two major requirements. One is a decision engine, and the second is a context agent. Let's use fraud detection as an example. So in fraud detection, the first requirement is you need a decision engine, or essentially the brains of the application. This is a solution that's able to take different data points you have on a transaction or user interaction, and it's able to process that and make a real-time decision. Say this is a fraudulent activity, this is a good transaction, or this needs to be flagged for suspicious behavior. The second major component is a context engine. So the decision engines are only as good as the context or the data points that you provide them. And over and over again, we see that models provide much better, superior business outcomes with enhanced context. So you need a solution that's able to take your enterprise data, combine that with, say, third-party data and other data sources, process that, transform that, and deliver that into that decision engine so it's able to make those smart decisions in real time. This is where Tecton and SageMaker work really well together, and why Arnav and I are joining together in this session. So Tecton is able to provide exceptional context, and AWS is able to provide exceptional decisions. So both technologies are platforms, which means they're able to manage the end-to-end lifecycle, as well as provide a foundational layer to these engines that we're providing, which is going to enable organizations to have faster time to value, reduce engineering costs, and reduce the total cost of ownership of this AI ML application. So when we look at the benefits that we were talking about in the first slide around increased revenue, decreasing costs, increasing customer experience, we see here we're also controlling for the costs of these AI applications. And when we work with these together, we're able to drive really positive ROI for organizations, leveraging these AI ML solutions. And as I mentioned previously, there's a new wave of ML models and architectures which need enhanced capabilities. And we're excited to show how some of our improved capabilities are able to meet those use cases need to allow those decision engines to be smarter while maintaining kind of our commitment to low time to value, low engineering costs, and low TCO. I'll pause here to see if Arnav, anything you want to chime in as we set up the problem statement here?
Yeah, thank you, Isaac. No, you summed it up really well. So I'll just emphasize that, the SageMaker AI as a tool is a platform that we provide machine learning engineers, data scientists, security teams to really build a robust platform that can help them build repeatable assets and processes that they can use to build models and deploy them at scale and not have to worry about the undifferentiated heavy lifting that a typical organization would be done. So we are going to do that undifferentiated work to make it easy for you to get your models out quickly and lower your engineering time and, of course, your total cost of ownership. That's what our focus is here. Thanks, Isaac.
Great, thanks. So let's take a quick look at the model architecture landscape. And there are much better summaries than this one. But one of the things I wanted to call out is over time, we've seen a shift in how organizations are building those decision engines. And from kind of primarily rule-based engines to adopting ML and using more tree-based or gradient boost-based models, XGBoost, it has and still is an exceptional tool for a lot of these solutions. But more and more, we're seeing a wave of new model architectures leveraging recurrent neural networks, LSTMs, adding memory to the recurrent neural network, as well as the introduction of transformer-based models, as well as transformer-based models with attention mechanisms. And these new model architectures are shifting both the requirements needed to provide context to that decision engine, and are also changing the model info requirements of these AI solutions. So today we're looking forward to discussing how Tecton is able to support kind of the contextual requirements of this new wave of models. And Arnav and AWS are looking forward to talking through how some of the work they're doing around supporting these model infra requirements. So let's dig into that a little bit more here. So first, on the Tecton side, overall, we're designed for complex data processing and feature computation. And what I'm going to be walking through in the next section is how Tecton is able to support some of the sequential features that are required for this new wave of models. And as well as some of the table stakes that we're going to provide you around ultra low latency, optimized retrieval, and the same enterprise grade governance, reliability, and availability as we generate the context for this new wave as well. I'll let you speak for the AWS side as well.
Yeah, absolutely. So, we've been doing machine learning stuff for the last 20 plus years. And as we've learned through those years is that what organizations really want for their builders is a unified environment where different teams can work together on different parts of the ML lifecycle and able to deliver value to their end business. So for that, we've not only provided you with a platform that does MLOps and experiment tracking and those kind of things, we've also partnered with multiple open source frameworks, PyTorch being the incumbent and the most popular, and create a variety of utilities like deep learning containers and deep learning AMIs that you could either use with our compute services like EC2 or EKS, or managed completely by SageMaker environments. And what this gives you is it gives you all the optimizations and the libraries, the curated stuff that have been built to run very efficiently at a low cost, high throughput on our hardware, on our EC2 machines. We've also provide developers with further insights into their model architecture, the training time, specifically if it's being done in a distributed fashion. As we know, model parameters are now hitting trillion size capacity, and they cannot be trained on a single GPU or an instance. So given that it adds further complexity, we are trying to help our end customers to fine tune this process so that they can put their energy and talent on truly the efficacy that they're trying to achieve from their models. On top of that, we partnered with a bunch of different accelerator providers. So of course we have a strategic relationship with NVIDIA for all the newer GPUs that they're coming out, Intel, AMD, and we also have our own homegrown custom silicon that we are engineering and have put out recently for customers to use. And right now, we support a variety of models, transformer-based, and we hope that it gives you the price and performance that you're looking for. With that, over to you, Isaac.
Appreciate it. So the first section for this webinar, we're going to dig into how to build the data requirements necessary for a lot of these model architectures, specifically focusing in the context of a real use case and fraud detection. So let's go ahead and dig into and work together to build out a mental model of what we're trying to build and accomplish with the feature engineering needed for a lot of these new model architectures. So overall, oftentimes a user, as they're making a transaction or kind of doing a different user interaction, they're going to have a history on that platform. And it's very difficult for a decision engine or any model to make a recommendation of whether a single action is fraudulent or not without understanding how that interaction or transaction relates to the history of previous transactions or interactions. So previously, if we're looking at kind of more of a gradient boost or tree-based mechanism, the process would be to engineer features associated with that. You might compare the current transaction with some historical averages. You might build out some lead and lag functions comparing current transaction with the previous one. But sometimes it would be very difficult to kind of engineer those features. So oftentimes we can look at a classic attack vector, which we show in this diagram here. In this situation, we have a customer who creates an account, adds a profile to that. They might log in successfully to their account. They might then add a card, run a transaction, add a card, run a transaction. And for each one of these, like first transaction on itself, this might be a $20 transaction. There doesn't seem to be anything nefarious around it, but this sequence of adding a card and then doing essentially a test transaction together is, you can just look at it, look suspicious, and it's a very common attack vector. Someone might buy a credit card off the information off the internet, open internet, and they might use this methodology to see, hey, are any of these credit card credentials actually valuable? So one of the new waves of models, so this focusing specifically on the recurrent neural network-based models, such as a LSTM, what we're going to be able to do is, instead of providing just one single transaction, we're going to provide a sequence of transactions. So we might say, let's pull in the last 100 or last 1,000 transactions, provide that sequential history to the neural network. Neural network is going to understand and learn patterns of sequences that may lead to fraudulent transactions. And so that at any given point in time, whether it's in training or inference, you're just able to provide kind of that sequence of events. So from a data processing perspective, what do we need to provide to these models? First, we need to be able to collect different events across different event types, whether that be transactions, clicks, logins, other account history. We need to combine them, build a sequential event history. Oftentimes, based off the model, you may also want to tokenize that sequential data. And then you want to be able to store that sequential event history and make it accessible so that at the time of inference, you're able to retrieve that sequence of n events at the 20, 50 milliseconds needed for these neural networks to be able to support those real-time decision engines. So today, I'm going to walk you very quickly through how you can create each one of those components. So first, I'm going to show you how you can define a data source, which is going to show how Tecton and the compute engines that we're building are able to connect to various event streams. Second, I'm going to show how to build a stream feature view, which is how Tecton uses, it's like essentially the functional unit of Tecton that defines how Tecton is going to be processing the data and computing the features. And then the second, last, I'm going to show a real-time feature view, which shows how you can do some post-processing on those sequence of events, which is particularly important for transformer-based architectures that are able to, instead of just processing kind of the sequential data one at a time, you're able to send the full sequence and calculate that in parallel. So a webinar is not a webinar without a quick demo. So I'm going to quickly hop over in Jupyter and kind of show you how you can do this with Tecton. So just to orient everyone, right now I'm working in SageMaker Studio Lab. where I have a Jupyter Lab notebook up, where I have logged in to Tecton, and I'm going to be working to interactively develop the features for this model. So as I mentioned before, the first step is I'm going to need to build out a stream source. So when you're building out a stream source, here first you need to identify a schema. So first I'm going to do is to kind of define the expected schema that I want for this data source. Second, I'm going to define a processor. This allows us to standardize the schema across different event types. And once I've kind of defined both of these components, I'm going to put those together into a Tecton object called a stream source, which is going to tell Tecton how to process this data as we're building out the stream pipelines necessary for this model. So we can see this in Tecton. It's relatively simple code. First, we're going to kind of identify our push config. Here, we're defining a way, essentially an endpoint, where either a stream processor or other stream connectors are able to push events into Tecton. And then the second component is going to be that stream source, where I've defined kind of within here, I've defined kind of our schema, our post processor, as well as kind of the end schema expected outside of this connection. And we can see a real example of the data here, where we have different user data, the timestamps associated, and the sequential history of events for each of those users. The next thing that we want to do is take these events and actually build them into a last n feature. So we want to be, so for, say, the last 100 sequences, we want to take these events and bring it into a vector that can be then provided to that model. So in order to do that, I'm going to be building a stream feature view. So here, the main components are we're going to take those row level events. We're going to define a source or locate the source, which we just defined in the previous step. We're going to define some transformation logic, and then we're going to define our aggregation. So this is going to be that last n that we're going to define in order to kind of get that feature vector that's going to be leveraged by that model. So within Tecton, our declarative framework, again, makes this really simple to do. First, within kind of our stream feature view decorator, we're able to define kind of the source. This is going to be that event stream that we just defined. We're going to define an entity, which is going to be the primary key that we're going to be doing our group bys on a given sequence. We're going to note kind of the mode of the transformation function. And here we're also defining kind of our last n aggregation. So this is able to, for each user, we're going to pull in all of the different events for them and provide that in a vector that's leveraged by these models. And finally, we have our transformation function associated with it. And if we run kind of the logic associated with this, done this ahead of time, just future-proof this demo, we can see a sample of this data of how we're able to take the row level data that was provided by the upstream sources that we've collected together. And we've now transformed and processed this data in a way that's able to be consumed by that model architecture. So what this enables you to do is with kind of a couple short lines of code, you're able to declare your feature logic here, and Tecton is able to abstract the complexity away. So we're going to take this code, we're going to apply this, which is going to spin up real-time data pipelines that are going to be able to process and populate this data in both a online and offline store, so that this data can be then retrieved by the model and service in ultra low latency. So that's a very short demo for this webinar session today. I'm going to close the loop on this with just one other quick call. So we're talking about sequential features. The last is going to be around transformer-based models. So I mentioned this briefly before, but for transformer-based model, one of the major distinctions between what we see, say, like a recurrent neural network, is that instead of processing the data sequentially, we're able to process that data kind of all at once, so the full sequence of events. So in order to do that, one of the extra steps needed is actually you need to tokenize the sequence of that data and make sure that that is available to the transformer model, so the different layers within that transformer-based architecture are able to understand the patterns of within the sequence itself. So one of the easy ways to do that, leveraging Tecton, is leveraging a real-time feature view, which is going to allow you to take that sequence and add additional processing on that, whether that's adding a new session or kind of tokenizing the timestamp itself. So that's a quick summary of how Tecton is able to support sequential features, which is the backbone of a lot of these new wave of neural network and transformer-based architectures. And with that, I'll hand it over to Arnab to talk through SageMaker.
Thank you, Isaac. That was great. So what I wanted to briefly touch upon is, based on what you saw, what Isaac did, he referenced of using the SageMaker as a tool for him to do this development. So what you're seeing on this slide is SageMaker AI can support you wherever you are in your journey on adopting machine learning within your organization. Whether it's traditional machine learning that is based on tabular inputs, so what we call legacy machine learning. So example use cases are predictive maintenance, risk prediction, demand forecasting. You can leverage SageMaker. With the advent of the transformer and deep learning architectures, we support deep learning typically in computer vision, sentiment analysis, topic modeling, and intelligent data processing. Of course, ChatGPT is taking the world by storm, so we have to support Gen AI as a part of our platform. So, SageMaker provides a bunch of open source models through our partnership with Hugging Face, including third-party models that are available through Anthropic and Meta's that are available on SageMaker for you to use directly for inference. We have a one-click deployment that allows you to spin up an inference endpoint that you can use to start querying. In addition, if you want to customize the models for your domain or your specific use case, you can use SageMaker AI to also do that. So end-to-end, SageMaker AI provides support for builders across every aspect of the machine learning lifecycle and inference. Next slide, Isaac. Yeah. So I briefly touched upon this in one of the earlier slides, but I wanted to really showcase that we are continuously investing in ensuring that when it comes to choice, selection, and price performance, we are the industry leaders in providing all the necessary accelerators that are available to you to harness this amazing technology that we've stumbled upon. With that, as you can see from our GPU-based instances, all of them are in partnership with NVIDIA, and we've announced a bunch of new instances that are coming up, which may not be updated on the slide, but we are going to be launching B200s and GB200 Ultra servers as a part of our immense scale in supporting deep learning with distributed training. When it comes to inference, you could use some of our G-based instances, so the G4, G5, G6, and the G6E. These are the newer based instances that use the L40S NVIDIA GPUs and offers better price performance than the previous gens. And finally, in the bottom, you can see our custom silicon that we have spent over 8 years building, and they are in two flavors. The Trainium focused on transformer-based models, whether it's vision image models or text models or your generation models. We use Trainium for that. And for Inferentia, there are two generations. Inferentia 2 is more well suited for larger models which spans billions of parameters or trillions of parameters. So that is something that we've invested in. And I also wanted to add here that it's very difficult for customers to ensure that they have a consistent container image that has all the dependencies and libraries. So we have made that easier for our customers to use deep learning containers that are free of charge. You just pay for the compute. You don't have to spend anything additional for getting these curated containers that are tuned to work extremely well on our EC2 instances using these accelerator types. I wanted to emphasize on that because I know working with customers, that's a big area of friction, and that can slow down the team. So we have innovated on behalf of our customers to make that available so that our customers focus on what is most important to them as they build out these models and deploy these models so they can get faster time to value. Next slide, please. So as I mentioned earlier, SageMaker is an end-to-end platform. And depending on the type of builders that are using the platform, what I try to describe this image is like a 3-layered cake. And we'll start from the bottom. Again, just in the bottom, you have the different types of compute options available, whether it's CPU, GPU, Graviton, which is our ARM-based instance, and Inferentia, which is our own silicon. You can choose from there. I briefly touched upon the deep learning containers that you can still use and deploy them on our machines, or let SageMaker manage it for you. Some of the other libraries you see in the bottom are through partnerships that allow you to host these models and extract, the optimized performance that we can make available. In the middle layer you see the different frameworks and libraries that we support. We support PyTorch, TensorFlow, MXNet, Keras, Gluon, Hugging Face, Onyx, and of course, NVIDIA's ecosystem, right? So NVIDIA Enterprise AI has their own versions of deep learning libraries and containers that we also support if you're using them on SageMaker. Finally, when it comes to developer productivity, we have the SageMaker Studio IDE that allows you to manage the entire life cycle of machine learning development. So starting from the data pre-preparation to the actual training, running experiments, tracking experiments, hyperparameter optimizations, ability to package it up and deploy in targeted environments. All that work, we do it through what we call SageMaker pipelines and SageMaker projects, really streamlining for builders, not having to reinvent the wheel as they embark on various different projects within the organization. One of the neat things is that you get the right level of governance and auditability that organizations typically require, specifically that are in the compliance areas like fintech, healthcare tech, etc. So it's a full-fledged platform. We are constantly iterating on it. We are adding new capabilities, and we are working with various partners to make it a one-stop shop. Next slide, please. So one last thing that I wanted to cover is it's not just about machine learning training, but also the observability during both training and inference. And for that, we have already partnered with a bunch of very popular open source projects. As you can see, we partnered with Grafana, and we have a managed Grafana implementation, one click for you to do visualization and debugging of your models during training as well as inference. We've integrated with open source project like ML4 for experiment tracking, running hyperparameter optimization jobs, tensor boards to track your model performance and accuracy details during the training run. And finally, we have used CloudWatch to integrate with, managed Prometheus to derive further container insights to really understand the overall compute and network and storage health of your platform, right? Where could be the bottlenecks? How is the GPU that you are paying for, is it being adequately utilized, and so on and so forth. So there's a tremendous amount of value that we have put into this platform to make the life of our customers very easy. And as you use Tecton to build different models, you get this out of the box and get to your business outcome that you're looking for. With that, I'll turn it over to Isaac.
Thanks. So just to summarize, one of the most exciting things about being in this space is that it's constantly evolving. We're seeing more and more model architectures being released. As an architect in this space, you always need to be on your toes. And Tecton and AWS are constantly evolving our capabilities to ensure that we're able to meet where you're at as an organization. Whether you're early on the journey, kind of working on role-based engines and some XGBoost-based model predictions, or you're on the leading edge working with a transformer-based architecture, we're going to ensure our capabilities are going to meet your requirements. At the same time, we're also going to honor our commitments, which are going to remain consistent throughout. We're always going to commit to a strong time to value. We're going to make sure that the both initial and ongoing maintenance and total cost of ownership are low. And we're going to ensure that we have enterprise-grade latency, scalability, and reliability. With that, I'll I fumble my words. I'll hand it over last to Arnab for the last call to action.
Thank you, Isaac. This is a great way to get started. If you're not familiar with SageMaker, we have a bunch of different QR codes out here. The first one is just for you to kind of get your feet wet, understand what is SageMaker AI, because there's a tremendous amount of modules that are there, and you don't have to start in a linear way. You can pick where you want to start, and we can help you there. The next thing is, we have step-by-step tutorials depending on the type of use case you want to build your model and deploy for. So definitely check that out. And then we typically run deep dive hands-on workshops. I think we have some that sometimes run local to you. So definitely scan that code and see what's out there for you to either do it on your own or register for a local event so that you can work with some local experts on your use cases or learn more about our platform. Of course, I am always reachable, so please don't hesitate to contact me through social media or my email. Thank you so much for your time and attention. Isaac?
Yes. Thanks, everyone. I hope you enjoyed this session, and we'll open up the floor for questions now.
Awesome. Great session, Isaac. That was awesome. We did get a couple of questions that I wanted to surface while we've got you here. First off, someone asked if you could talk a little bit more about how Tecton ensures consistency between the sequences seen during training and those served in real-time inference.
Yeah, good question. So first of all, training and serving consistency is super important to ensuring your models are performing at the time of inference as well as they're performing at training. So Tecton offers a couple capabilities to ensure that training serving skew is minimized, as well as we're avoiding data leakage. The first is going to be our declarative framework. So within that example you saw, we were just finding our feature view once. And behind the scenes, Tecton is going to build data pipelines that are able to populate that data within the online store, which is used at the time of inference, as well as in the offline store, which is used for training. So you don't have to worry about code drift between your training and inference paths. The second piece is around time travel. Tecton offers a ability at the time when you're retrieving data for training data set generation to go back in time, identify what features were present at that exact point in time to ensure that we're providing those point in time accurate features to the training data sets being leveraged by that models. In parallel, both of them are enable us to provide better model performance, better decisions by ensuring that we are minimizing that training serving skew as well as data leakage.
Makes sense, super important. One follow-up that's kind of related. You mentioned post-processing with real-time feature views. What kind of transformations are typically done there for transformer models?
Yeah, I think this hits on a key distinction between transformer models versus other kind of deep learning models, such as recurrent neural networks, LSTMs, GRUs, and it's how they process data. So recurrent neural networks, being an example, those are going to be processing data sequentially, whereas transformer-based models are going to be processing data in parallel. So transformer models need a way to understand what is the positional how each one of these tokens is positionally kind of located in that sequence. So oftentimes teams are going to be using real-time feature views to encode those positional embeddings and provide those to the transformer model. In addition, real-time feature views can also be used for some additional processing. So it's also common to kind of do any type of padding within a real-time feature view as well.
Got it. Awesome. Another question that came through is around your latency comments for like inference time workloads. How do Tecton and SageMaker split those responsibilities in terms of latency and resource utilization?
Yeah, so I think latency is one of the biggest challenges with real-time decisioning. Oftentimes we're given a latency budget of 200 milliseconds, 300 milliseconds, even lower. And it's usually not just one decision. There's a bunch of micro decisions being made within kind of this overall decision engine. So in general, Tecton is, as I mentioned previously, is going to be that context engine. It's the process of retrieving all of the features needed to make that decision, and then usually doing some additional enhancement of those features, oftentimes using something like a real-time feature to enhance that context even further. And then the actual decision side is going to be owned by SageMaker, where they're going to be running the different rules engines, different models, in order to take the features that we've provided and actually use those to make your model predictions, and then use those model predictions to make your decisions based off of the different thresholds that you've assigned.
Perfect. Last question that came up. What role does traditional machine learning and rules engines play in modern real-time decision engines?
Yeah, that's a good question. I think one thing I would want to call out is it's not just one or the other. Most organizations are leveraging a combination of role-based engines, traditional ML, deep learning models, transformer-based models, foundational models, because they all have strengths and weaknesses and are all used in different areas of your ML and decision-making stack. I think the major distinction I would just highlight is that your rule-based engines and as well as some of the traditional ML models like a gradient boosted decision tree, they are going to be great when you need fast interpretable decisions and where the signals or the features, as we call them, are obvious and can be kind of built relatively easily. The deep learning models, they are fantastic for kind of parsing out some of those non-obvious signals and attack vectors. And so each one has different strengths and weaknesses, and we usually see a combination depending on that use case. The last thing I would call out is that I haven't seen too many organizations jump straight into deep learning techniques and being successful right away. I would really encourage everyone to start simple, start with your rule-based engine, start with some of your traditional ML that are fast and interpretable, build out that flywheel, and then as you grow as an organization, you can start leveraging some of these deep learning techniques around that.
Really good advice. Yeah, super cool to learn about the advanced stuff, but everyone has to start somewhere. So thank you for running through those. We're going to take another quick break. Sergio is going to walk through an account takeover demo while we're taking a break. But Sergio is here to answer questions about the demo. So if you have them, please drop them in the chat and Sergio will get to you. So yeah, anyways, ask away, enjoy the demo, and we'll be back soon. Thanks, everyone.